So now I will explain. You all can open your Excel file in your PC. Please go to your PC. Open your Excel file. Could you please open an Excel file? Open Excel file. Able to see the Excel file?
Yes, sir.
So first, let us say first column will be pickup. Okay, pickup. Pickup. Okay. Next column is your time multiplier setting, TMS. Last class I have told you what is pickup and what is time multiplier setting. Next column is the current and next column is the time. So this pickup and time multiplier setting, you have to give this current and time, it will calculate. Remember, if I change the last time itself, I told you if I want to move my curve left and right, I have to change the pickup. If I have to move my curve top and bottom, I have to change the TMS. Okay. So pickup current, let's say I will give the pickup current as see let's how to calculate the pickup current also. I will tell you. Suppose let's say my CT is uh, 630 amps bar 1 amp CT. Let's say it's a 630 amp bar 1 amp CT. Okay. So pickup one means 630 amp. Okay. Now suppose let's say the load. Okay, the load is it's 11 kV. Let's say it's a 5 MVA load. 5 MVA at 11 kV is how much? Pinaki ji.
1 second, sir. I'll work it out, sir.
Yeah. Others also can let me know what is 5 MVA at 11 kV.
Two 262 amps, sir.
262 amps. Okay, sir. 262 amps. Right.
Yes, sir.
Okay. So if I want to take 10% extra load of this, okay, I don't want to, initiate my relay to pick up immediately. Let me overload at least 10% of this. So 262 into 1.1 is how much? 288, right? 288 amps. So now 288 divided by 630, okay? The primary current. So 0.457 is my pickup setting. Is this clear?
Yes, sir.
Now I will go to my breaker. Last
Sir,
time.
1 second.
Yes, sir.
After 288, what is it? Can you repeat?
Yes, sir. I will repeat. See, after 288, 288 is the current I got. Now to find the pickup, divide 288 by 630 amps.
Okay, sir.
630 is the CT primary. So I got 0.45. Now let me go to my last time. I showed you the relay. This one data sheet of the ABB relay, right? I will open again that one. I will share that screen again. Let's stop this there and I will share. Are you able to see this one? So now here, what is the pickup range? It is 0.5 to 2.5. Okay. Okay. IDMT. See, this is actually 51 low stage. Actually, in ABB, you have one more 51, which will be high stage or something. Okay, the pickup is, it starts from 0.5. So I cannot give a pickup here of 0.4, right? So the minimum itself is 0.5. The relay minimum is 0.5. So now if I keep 0.5, what will happen? See, if I keep a setting of 0.5, I cannot, actually speaking, when we choose, that is, see, this is, here I want to tell you one thing. When you are selecting a CT, no, you have to be very careful in that also. So maybe in this project, if you were a design guy in the beginning, or if you have reviewed the SLD, or if you have reviewed your drawings, you should have told that don't go for 630 amp CT, better go for a 500 or 400, or better go for a 250 amps. Like that, we could have suggested them to go for some other like 300 amp CT, something. You could have suggested them in that stage itself. Okay. Because the CT what you are selecting now, see here I have to go for 0.5. This is really actually it is not correct. I cannot see what is 0.5. 0.5, how much? It is 0.5 of 630 amps. Is 0.5 into 630 is 315 amps, and 315 amps is how much? 315 amps is nothing but 1.2 times. In other words, from 1.1 to 1.2, till 1.2, I am allowing a continuous overload. Okay. So, in this project, the first place, I have to tell them that the CT should be 500 amps. Okay. Because when you are doing coordination, your equipments are still not manufactured, right? So you can tell them that please change the CT. It is not a difficult thing. So let's go for primary. If I go for a 500 amps primary, then what will be my this one? 288 amps divided by 500 amps will be 0.576. So I can tell them instead of 630 amps, go for a 500 amps primary. Okay, so 0.576 is what I got. See, there is nothing wrong. Somebody may tell you, hey, your work is to do coordination, just do coordination. Who asked you to talk about CT, all this? The equipment is already in the factory. It will get delayed. Now we can't change. So people may tell that, but you tell them, look, in the actually, I agree that I'm a relay guy. coordination guy. It is not my duty to, comment on this. But you guys should have done this in the beginning. When you made the SLD, you guys should have thought about this. Okay. If the load current is 250 amps and like a 630 amps CT, that is your mistake which you have done in the past. So I can't help it since you have done mistake. I am correcting it. Please go for a 500 amps CT. Okay. So 0.5 to 2.5 in steps of 0.0001. Able to see the Excel?
Not
Excel is not coming, sir. This table is coming now. Setting range table.
Okay. Okay. Now able to see the Excel?
Yes, sir.
Okay, sir. So what I will do, I will change my seat. I will take a CT 500 amp secondary. Okay, because 630 amp secondary, if I take primary, if I take, then I have to keep the minimum pickup itself at 1.2. That will be very. I have to have pickup at 1.1. So if I take 500 amps as the CT primary for a 262 amps, 262 by 500, I will get 0.5764. So this one minimum setting is 0.5 in steps of 0.001, right? So I will go for the setting as 0.576. Okay. So my pickup will be 0.576. Okay. Now let me take my time multiplier setting TMS as 1. Later on we'll change this time multiplier setting. Okay, we'll play with it. For the time being, you take it as 1. Now coming to the current. Okay. The current, okay, when you start plotting, you take the first current as 1.1. Okay. Now what is the time? What is the equation? Let us go to this again. Able to see the PPT again?
Yes, sir.
Yeah. So now let me choose a normal inverse curve. For the normal inverse curve, what is the equation? Numerator divided by denominator. Numerator is K into beta. K is the time multiplier, beta is a constant. So here, hold on, just 2 minutes. Please write down this equation in a piece of paper. T is equal to K beta divided by I by I set to the power of alpha minus 1. Please write down. And let K is the time multiplier setting TMS. Beta, let us choose a normal inverse curve. So beta will be 0.14. I by I set. Okay. Alpha you choose as 0.02 minus 1. I hope you have written down this. I will go back to the Excel. Okay. So here, what is the equation? You know to write the equation. This is equal to numerator divided by denominator. So I will put a see, I will put this bracket divided by denominator. Okay. Then numerator will have time multiplier setting. This is the time multiplier setting multiplied by a constant 0.14. Okay. Okay. Equal to multiply by time multiplier setting into 0.14. Okay. Then new denominator has two terms. So I will put one more bracket minus 1. Okay. Now this bracket is basically, it is a power of a number, right? A divided by B. Okay. So I will say power of a number, and this is that number, comma 0.02 is a power, and this number is nothing but two term, one divided by the other. That first term is the I by I set. I is the actual current and I set is the pickup current. Okay. So I get my time.
10.75002. Yeah.
Actually, what is 0.576? Is it 10 times? Uh, 500 amp CT. Yeah?
Do it in the form of
500 amp CT. What was the current you told me last time? 5 MVA?
5 MVA is 268 amps, sir.
268 amps. So
5
268
MVA, no,
amps.
you mentioned. One second,
Yeah,
one
yeah,
second,
yeah.
sir.
62.
262, huh?
262.
262 amps. So now 262 amps into, so 262 amps, 10% if I overload, it will become 288.2. The 288.2 amps at 500 amps will become 0.5764. Okay. So suppose I keep the pickup. So I is nothing but 1.1. Okay, here, okay, you please see here. What is I here? I is not 1.1, because I is the current in per unit, actual current seen by the CT. And the actual current seen by the CT here is how much? In the beginning, it is 0.576, right? What is the see the actual current seen by the CT in the beginning, in the start? See, when there is no fault, what is the current seen by the, what is the current flowing? It is 262 amps, right? So
Yes, sir.
when I start the curve, I have to start my curve with the first, when you start doing the relay plotting, you have to take the 10% of the, whatever is your pickup, that is the first current you have to plot here. So 1.1 times 262 is nothing but 288 amps. 288 by 500 is 5764. So my first this one has to be 5764. Okay. And that time I will get it as infinite. That is
One-
okay. That is
One
correct.
second, sir.
Yes, sir.
1 second, sir. Can you please just explain once more, one moment? You're keeping it at 630 amps or wait, 1 second. You're keeping it at CT as primary. So when you keep 0.576 as a pickup, when the current is 0.576, its infinity means the relay will not operate, right, sir?
Okay, sir. In the first, it is no longer 630 amps. I told you 630 is a wrong design for CT.
Right. It's 500.
It is 500 amps. Yeah. Now, see, when you set the first setting, the pickup at 1.1 is infinite, means it will not operate.
Right. That's what
When
I
you
wanted to
slightly increase above 1.1 time only, it will operate.
say. Okay, sir.
Okay. So now, see, these two terms will remain same. Pick up for the entire table. Okay. Now, I will take my current. Let me increase my current from. Let me increase it by 0.5, 0.5. Okay. To this, I will add another 0.5. To this, I will add another 0.5. Okay. And this one is a formula. So here you will see when my current is okay 0.5 how much? What is 0.5 is 250. 0.5 is around 250 amps. Fine. So now let's what okay 5 MVA transformer. Let's say the impedance is no, the per unit impedance of the transformer will be how much? 6% or 7%?
So
Okay,
we use 7%.
7%. Okay, 7%. So the fault current will be around 14 times. Okay, so I can plot my current up to like 15 times. I can plot. Okay, this is 15 times of 262 amps is how much? 262 into 50.
3930.
How much? 3. Okay, up to 4 kA. So if my current is 18, let's say my current is 15 of 262. Okay. So okay. So what basically I'm telling is, I told you where to start, but I am now telling you where to stop. See, there is no point plotting the curve, till 100 or something. Okay, I will stop it at, let's say, up to this point. Okay, not beyond this. Okay. Now, please see the screen. Everybody is seeing screen.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
You select this, this cell. After you select this cell, you click your left mouse button and you select this complete table like this. Okay. Then you right click. Then I think this insert will not work. You have to go to insert here at the top. Okay. You press this insert. And after you press the insert here, you press this one. Insert, you press this one, scatter, insert scatter X and Y. See, there are two curves here. Insert line, insert scatter. You press insert scatter X and Y. And here you take this one, scatter with smooth line. Okay. Now my question is, what is x-axis, what is y-axis? Did I get?
X-axis is current, y-axis is time.
Oh, that is not okay, no? I don't want.
No, x-axis is Yes, as per this,
X-axis current, huh? Okay, fine. Then it is
yes,
okay.
sir, correct.
Okay. Now I want X-axis as a logarithmic scale. So what do? I go to format axis. Yeah, I select here logarithmic scale. Okay.
Sir, 1 second. How did you do that, sir? You do the
Right
right click
click.
and then,
You go.
yeah.
You press right click on this one. You press here. You right click
Uh,
here. You go to format axis. The moment you say format axis, you select logarithmic scale. Okay. Clear?
Axis, logarithmic scale base 10. Okay, sir.
Okay. Is that clear?
Yes, sir.
Okay. Now this is the incomer. Okay, breaker. So I can add some name for this. Add a data label. Oh, don't want. I will not add. It's too many. Uh, data series. Okay, this is okay. Now here, this up to here clear. Anybody, any doubt
sir.
here?
Yes, sir.
So you know how to create a table in Excel. You know how to plot that curve. Okay. Now let us add what all we have to add. We have to add damage curve of a transformer, 5 MVA transformer. We have to add starting curve of the motor, and we have to add outgoing feeder curve. Okay, if we do that, that's then we can do the coordination. Okay, so I think for today we'll save this and we will close it here. So tomorrow we will take up adding damage curve, adding motor starting curve, then adding the outgoing breaker curve, and then we will do the we will play with the curves. We will change the curve type. We will change the TMS. We will not change the pickup. And after doing all that, we will finalize the curve. Then we will similarly do curve, the same sort of curve for one more feeder, which is the transfer, low voltage transformer outgoing feeder. After we do all this, finally we will extract all this information, put it in a table. Okay. Okay, sir.
So